This video describes how to run an R program to create a total operating characteristic curve, also known as a TOC curve. It will be helpful to read the article, The Total Operating Characteristic to Measure Diagnostic Ability for Multiple Thresholds by Pontius and Si, in addition to watching this video. You can find this article on Robert Gilmore Pontius's ResearchGate Profile by using the link shown on the screen. A TOC curve measures the ability of an index variable to diagnose either the absence or presence of a characteristic. The diagnosis depends on whether the value of an index variable is above a threshold. Each threshold creates a 2x2 contingency table which contains 4 entries: hits H, misses M, false alarms F, and correct rejections C. Here is an image of a TOC curve. The unit on both axes indicates the number of observations, which we express as area for our case study. The horizontal axis ranges from 0 to 20.5 thousand square kilometers, which is the size of the study area. The coordinate on the horizontal axis indicates the size of presence and the diagnosis for a given threshold, hits plus false alarms. The vertical axis ranges from 0 to 1.3 thousand square kilometers, which is the size of presence and the reference variable. The vertical axis indicates the hits for a given threshold, hits. A horizontal line called hits plus misses defines an upper boundary of the TOC space because the vertical coordinate for all points in the TOC space must be less than or equal to the number of observations that are reference presence. The maximum and minimum boundaries in the TOC curve form a parallelogram that contains the mathematically possible space where the TOC curve appears. The maximum boundary represents a hypothetical index variable for which the highest ranking observations of the index variable correspond with presence for the reference variable. The minimum boundary represents a hypothetical index variable for which the highest ranking observations of the index variable are associated with absence for the reference variable. The TOC curve is an improvement upon the ROC curve. The ROC curve also measures the ability of an index variable to diagnose either the absence or presence of a characteristic, however, fails to produce sufficient information to fill out a contingency table. The TOC curve reveals the size of every entry in the contingency table for each threshold.
There is an R package called TOC that allows you to input an index variable, a Boolean variable, and a mask to create a TOC curve. Now we will show you how to use this package to create a TOC curve. Open the R software. You must use version 2.14 or newer of R, or the TOC package may not work. To download the TOC package, click on Packages on the top toolbar, then click on Set CRAN Mirror to select a server to download the package from. A window will appear to allow you to select a server. Here we chose USA Kansas because TOC is available on this mirror server. Once you have your mirror server chosen, click OK. Next, click on Packages from the toolbar and select Install Packages. This will launch another window that lists all the packages in the server. Scroll down until you find TOC, select it, and click OK. Now the package will be downloaded. Once the package is downloaded, the program will display the line, "The downloaded binary packages are in," and will show the file path. Next, you must load your package because it will not be automatically installed in the R program. Click Packages in the toolbar and select Load Package. The Load Package window will show you all the packages you have downloaded. Select the TOC package and click OK. Now your TOC package is fully installed and you can run any of the example codes in the TOC manual to create a TOC curve. Here is the first code. You must specify which data you will compare by changing the file paths in the code. The index is your objective class numeric or suitability map of thresholds. The Boolean is your Boolean objective class numeric or map of pixels that have changed. The mask is the mass objective class numeric or maps of candidates for change of your study area. Please note that you must use forward slashes in the file path, although the default for Windows is a backslash. Once you input this code, hit Enter on your keyboard. Here's the code to create the TOC curve. The double hash sign indicates a comment that will be ignored in the code. The first line, TOCD, compiles the data from the input variables. You can change the nthresh variable to change the number of thresholds that the code will run. The second line, plot, plots the TOC curve in a graphic window, and you can change the title by editing the text inside the quotations. Make sure you save the plot image to file before you run another line of plot code, or you will lose the older TOC graphic when the plot function overwrites it. This next code shows an example of how to label the thresholds in the TOC curve. The threshold labels correspond to the value of the thresholds in the index variable. Note that the first line is nearly identical to the TOC curve, but it has reduced the number of thresholds to 10, so the threshold labels will be visible in the plot. In the second line, the label thresh variable can be set to true or false to turn the threshold labels on or off. Pos L specifies the position of the text labels. Values of 1, 2, 3, and 4 respectively indicate the positions of below, to the left of, above, and to the right of corresponding coordinates. Here's a side-by-side comparison of the two outputs of the code. You can see how the nthresh variable affects the graph. It may be helpful for analysis if you create a TOC curve with and without labels. By having both plots, you can examine the trend of the TOC curve as well as see specific threshold values. Please use this code when you are diagnosing the presence or absence of a characteristic by comparing a Boolean variable with an index variable, such as a suitability map. This code can be an important tool for signal detection and diagnostic systems, especially in the fields of genetics, radiology, medicine, and land change science, among many other applications. Follow these links for literature and the TOC package and manual for the R program.
Thank you for watching this tutorial, which is sponsored by the National Science Foundation and the Long-Term Ecological Research Network.